All right, we're continuing with studying some more complicated shapes than we've looked at in the earlier parts of a college algebra course. We're going to look at this time we're going to look at a hyperbola. It'll be described as a bow tie that extends off infinitely in either direction. And so if you see here, if you imagine, we've got two different versions of it, of course. We've got, if we're centered here at the origin, we've got a bow tie going off along the x-axis, or you could be going vertically. We have the bow tie extending in each direction. So here's the center of the tie, and here's the two ends extending off. Now, the formula is going to look very similar to what we were just looking at. The only difference is this time we're going to have a negative in between. Instead we had x squared over a squared plus y squared over b squared. So it's identical in every way except for a minus instead of a plus. Now our transverse axis is going to be our major axis. Get back to the picture here. Our transverse axis is the major axis which the bow tie is sitting on. So if you look here, this is a transverse axis going along the x. Here's a transverse axis going up and down along the y. Now I don't love the way they do all the different letters, but so if we're on the transverse axis here, the a squared, we can square root that just like we did before to find the vertices. Now again, this is the one where the major, this is similar to what we saw before. The major transverse axis on this one is under the x, but sometimes it's under the y. We'll look at that one in just a second. So the transverse axis is that major axis, it's 2a. If we want to find the vertices, we're going to add that value of a and subtract it. And then the length of the conjugate axis then is going to be dependent on b here. We can find those co-vertices. That isn't going to be very essential in this picture. It doesn't do anything really to help us graph it. But this time, to find the value of the foci, it's going to be the Pythagorean theorem. This time it's going to be c squared equals a squared plus b squared. So it's not a minus this time. It's going to be a squared plus b squared like it always used to be. And then we can add or subtract the value of c. In every other respect, it's going to be the same. Now we have just one last change. Let me get back to the picture here. So we have these diagonal lines that are going to serve us as asymptotes that are going to help define the shape of the bow. And so they're going to be defined by a line. There's going to be two versions of it. There's going to be a positive sloped version and a negative sloped version. Now all this notation here is a little difficult to understand, but just remember, y is the slope of a line, I should say. M is the change in y over the change in x. So whatever value, they keep changing the letters here, which I don't like, but whatever value corresponds to the y, so whatever value is under the y is going to be the top of the slope, and whatever value is under the x is going to be the bottom of the slope. Now it's a or b, so we're going to square root them. So let me get into it here. You'll see the other version here real quick where we flipped it around, where this time we're going to be going vertically because the major axis, the transverse axis, is under the y. So this time we'll be going up and down. So this one's going right and left because the major axis, the transverse axis, is under the x squared. And this time we're going to be going vertically because it's under the y squared. Now let's do some of these and it'll make some more sense. It isn't really all that hard. It's a little hard to explain, but okay. So all this once, we don't have to graph this yet. We want to just find the vertices and the foci. So let's get started here. Now we know this is under the y, so that's my value. It's going to be my a. So we're under the y, and so a is going to be the square root of 49, so a is going to be 7. And now b, well, do we need it here? We don't really need b, so b is going to be the square root of 32 if we needed it. Okay, so we know a, they did a lot of work that's not necessary. We know that a is just going to be the square root of that. And we know b if we needed it. What we do want is to find the foci. And to find the foci, just like we did before, we're going to use our formula, but it's now back to being just c squared equals a squared plus b squared. Remember in the last section it was a squared minus b squared. Here it's just the good old Pythagorean theorem. And so let's crunch it. We put in a squared is 49, b squared is 32. We add those together, solve it, we're going to get 9. Okay, now our vertices are plus or minus 7, and the 7, this is going up and down vertically. because it's under the y, so it's going up and down vertically, so my two vertices are 0 plus or minus 7. So 0 and 7 and 0 and negative 7. We're going up, we're going down. Okay, now how about the foci? We are at 0, 9. Hold on, I got to think that through. I thought there should be 2. Yeah, there should be 2. Yeah, they didn't do both. I wonder what was going on there. Okay, so we have 2 foci, so we're at 0, 9 and 0, negative 9. So the foci are along that major axis. They're along the transverse axis, so they're going up and down as well. And we know C is 9, so we're going up 9, down 9. Those are 9s, even though they don't look very good. Okay, now let's try one ourselves here. So this one is first, and it's positive. It isn't the size of the number. It's not that this is the smaller number. It's that this one is positive. So that makes it A. So we're going to call A is going to be 3. B is going to be 5. Remember, there's square roots of each of those. Okay, now C is going to be... Now I'm jumping ahead, but you see what it was doing? C squared equals A squared plus B squared, so I'm just square rooting it. So that's where the 9 is coming from, because that's A squared. B squared is 25. And then we don't want C squared, we want C, so we're square rooting this. We get C as the square root of 34. Okay, so we've got A and we've got C, and all they want are the value of the foci. Now, we're on the x-axis. The hyperbola is going right or left. It's something like this. Our bow tie is going horizontally. So if we want our vertices, we're going to be going horizontally. So we're going 3, 0 and negative 3, 0. I'm going with this guy right here. 3, 0, negative 3, 0. All right, now they want the foci as well. It's going to go along that same axis. It's going to go horizontally. So we're going to have positive square root of 3/4, 0, and negative square root of 3/4, 0. Okay. Yeah, we've seen this before too. Let me just, we want to find the standard form. Yeah, well actually this isn't what I thought we were doing just yet. So they're going to give us the vertices and the foci, and we're going to have to make the equation. Well, this isn't so hard. So if we know the vertices, and it's happened on the x-axis, so we know that the x squared is going to be the positive one, because our transverse axis is along the x-axis. So A is going to be 6, because the distance from the origin to the vertices is 6 in either direction. So that's going to make this 36. Okay, now the foci tell us the distance. So we've got minus y squared. We need b. We don't have b yet, but we do, and we always know it equals 1 every time. Now we know c is 2 square root of 10, because it's the distance from the origin to this foci, either way. So 2 radical 10. So what we're going to do to find b squared, we know a squared plus b squared equals c squared. So I know 36 plus b squared equals 40. So I'm just squaring 2 square root of 10. So that squares this, makes that 4, times 10 gets me the 40. I've got b squared equals 40 minus 36, sending that over. B squared equals 4, so b is going to be 2. Now we don't have to plus or minus this because this is a length here, so b is 2. We don't need the minus. All right, so if b is 2, b squared here is 4. And that's all we need. Oh, yeah, their answer's down here, but we did the same thing right here, same thing. Now, I don't think that's, yeah, we're going to graph it, I think, in the next video. All right, now let's try one ourselves. If you want to pause it, want to give it a try, that'd be great. Now, what I see here is that our transverse axis is along the y. It is going vertically because we're moving here along the y's. So my value of a is going to be 2, and y squared is going to be the positive value. So I've got y squared over a squared is 4. Now it's going to be minus x squared. Now c is going to be 2 square root of 5. So to solve for b, we're going to do a squared plus b squared equals c squared. So 4 plus b squared equals 4 times 5 equals 20. So b squared is going to be 16, b is going to be 4. And so we know b is 4, well b squared is what we need for the equation. So here is my equation. All right, now just like we saw in the last section, 8.1 I believe, we are not always centered at the origin. So we're going to move in just the same way we did before. Everything's going to be the same except we have h and k. Our vertex is going to be moved. Just remember, as it's been every time, this formula is built with a minus here. So just keep that in mind. H and k are built with the minus. And of course we have the minus in the formula as well. Now we're going to have two versions of this. Everything else is going to stay the same. So yeah. So a lot of this is going to look real confusing. We'll talk about these in the graphing section to create these asymptotes. We haven't needed it in this section, and we're going to leave that out of it for now. So, okay, we're going to write the standard form of this equation. The first thing we need to see is we got to find the center. Where is HK? Now, look what's happening here. These are our two vertices, and they're changing along the x-axis. Do you see the y values are staying the same? So what I need to do is find the middle of these x values. I could average them 0 plus 6 divided by 2, but I know the center of this is going to be the center of this hyperbola. Can you see that this is going to be 3, negative 2? You see the y values are not changing at all. You could think of this as averaging the two x values. 0 plus 6 divided by 2 is 3. So here's my center. My center is at 3, negative 2. And so what is the distance from this center to either end? It's 3. So A is going to be 3. And C, what is the distance from my center to these foci? Well, the distance from 3 to 8 is 5. You see we're traveling along the x-axis. We're at 3, negative 2, and we're trying to get to 8. 3 to 8 is 5, or 3 back to negative 2 is 5. So just like we had before, we have our A, we have our C, we have our center. I don't want to write over there what they're doing here, but so I'm going to do a squared plus b squared equals c squared. A squared is 9, c squared is 25. Okay, just solving this, I get b is 4. Okay, we have everything we need. B is 4. Now, our transverse axis was along the x, so that's telling us x squared, oh sorry, we moved our center. So here's my center. X minus 3 all squared. H and K right here, and it's built with a negative in there. So x minus 3 over my a squared is 9. Now that puts y plus 2. Do you see it's minus a minus, so that makes it plus 2 squared. And let's see, put b under here, so that's b squared is 16. And all of that always equals 1. So they're just doing everything we just did. Okay, now I'd love it if you want to pause the video and try this on your own. It's going to be the same process here, but I'll get started. Now, I'm looking for the center. The first thing I need is the center, and if you look at this, can you see here that the y's are changing? So our transverse axis is going vertically, and so also y squared is going to be the positive value. Now where's my center? So we're going, center is at 1 because the 1 isn't changing, but I need to average 8 and negative 2, and so I'm finding the center of these. So there's a distance of 10 there. So hold on, 8 minus 2. I'm trying to think if I'm doing that right. Okay, 6. Yeah, so it's at 3. So you're going to just average those. 8 and negative 2 divided by 2 gets me 3. So my center is at 1, 3. Now, what's the value of A? Well, A is the distance along that y-axis, because we're moving along the y, from 3 to either 8 or down to 2. So it's the same in either case. It's going to be 5. Okay, so we also need C if we want to be able to go forward with this. So let's do C. Now we're following the foci here. So we're going from this center 3 all the way up to 16 or back to negative 11. It doesn't matter which way you go. So from 3 to 16 is 13. Okay, so we have, hold on, I lost track of what I was doing here. Yeah, that's right. Okay, so we have A and we have C. So we need to find B by doing, I'm just going to jump ahead to 25 plus B squared equals 13 squared, which is 169. Make sure I'm right about that. Equals 169. B squared is going to be 169 minus 25. So B is going to be 12. Okay, now let's build it. So we're going to go, Y is going to be first. So we've got Y minus the K here squared. And we're going to put this over our A, which is, where was our A? A squared is 25. Now we've got minus x minus our h, which is 1. All of that squared. So h goes with x, k goes with y. The y was the first one, the positive one, because we're moving along vertically along the y-axis. And we needed b here, which is 12 squared, or 144. And all of that equals 1. Okay, so hopefully that's a good introduction to this. We're going to graph them in the next section. We'll talk about those asymptotes when we get to that in the next video.